This video is to help you learn to use the methods of Hamilton and Jefferson for apportionment. The definition of apportionment is the problem of dividing up a fixed number of things among groups of different sizes. In government, we use apportionment to determine how many representatives each region receives. There are several rules for apportionment. The first is that the things being divided up can exist only in whole numbers. So we cannot divide a representative, a person, in half between two states. Also, we must use all of the things being divided up and we cannot use any more. So if there are 435 representatives that we need to divide amongst regions, we have to use all 435. The third, each group must get at least one of the things being divided up. And then the last is that the number of things assigned to each group should be at least approximately proportional to the population. So if you have a larger population, you should have more representatives. A smaller population should have fewer. Here's an example. Suppose a parent is giving away pieces of candy amongst 5 children based on the number of minutes they read that week. And so here are 5 children, A, B, C, D, and E, and the minutes that they've read throughout the week. So if we want to divide 30 pieces of candy, suppose, the first thing we want to do is find a standard divisor. The standard divisor is the total population, so we add all of the minutes in this case, divided by the number of seats. The seats in this case are the pieces of candy. That's what we're dividing. So in this example, we have 750 minutes divided by 30 pieces of candy. That gives us 25 as our standard divisor. Then for each child, we want to find the standard quota. This would be the exact amount of candy that each child should receive, but usually will result in a decimal. And we know by the rules of apportionment that we have to distribute the candy in whole numbers. So the standard quota will take the population of each state, or in this case, each child, and divide by the standard divisor. So looking at this example, I've found the standard quotas for each child. So for child A, they read 188 minutes. We divide that by our standard divisor, we get 7.52. We do this for each one of the children. 142 divided by 25, 138 divided by 25. We divide each one by 25. Then what we want to do is we want to look at this and say, what are our options? Well, we could round each value down. And in that case, that would be taking our lower quota. If we round this down, we'd have 7, 5, 5, 2, and 8. But if we add those up, we only get 27. And all of the 30 candies are not used. If we round it up, then we would have 8, 6, 6, 3, and 9. That results in 32. So we have more than 30 pieces of candy. If we round normally, we would still result in more than 30. So none of those methods will work. Alexander Hamilton, the one famous from the musical, as well as historical background, came up with this idea. So he took the first 2 steps. He found the standard divisor, take the whole population, divide by the number of things divided. Then take each state or each student and divide their minutes by the standard divisor. That gives us a standard quota. Then he said, let's drop the decimal. These are our lower quotas, so we're rounding down and add them up. If we end up short, what we want to do is give the remaining pieces to the group with the highest decimal place. So we'll look at a few examples of this. In our candy example, as we saw before, standard divisors gave us 7.52, 5.68, 5.52, 2.56, and 8.72. Our totals rounding down only gave us 27 pieces of candy, so we need to allocate 3 more pieces. We looked at the standard quotas with the largest decimals. In this example, B, D, and E have the highest decimal to the right, so we distribute one extra piece of candy to these children. The final apportionment here would be 7 for child A, 6 for child B, 5 for child C, 3 for D, and 9 for E. So that's Hamilton's method. In this example, we have 3 counties in Delaware, Kent, Newcastle, and Sussex, and their county populations. To find the Hamilton method of apportionment, we follow the same steps as the previous example. First, we find the standard divisor. This means we need to divide the total population by the 41 members of the House of Representatives. So that's given in the initial statement. Step 2, we find the standard quota for each county. So we take each of the county populations and divide by 21,900 and a long decimal. So I've done that calculation here. Our standard quota is this column, and then we find the lower quota for each county. And all we're doing there is dropping the decimal place. So 7, 24, and 9. The total there is only 40. So we need to give 1 seat to one of the 3 counties. Again, here's our same chart. And we need to add 1 seat by the largest decimal. We look up here, we have 0.411, 0.58, and 0.00. So that Newcastle County is the highest decimal place. We move their allocation to 25. Kent and Sussex stay the same at 7 and 9. The next method is Jefferson's method. This is Thomas Jefferson. He followed the same 2 steps as Hamilton. So he found the standard divisor, he got the quotas, actually the first 3 steps, and also found the lower quotas. The last step is where it differs from Hamilton's method. Jefferson said, rather than allocating the remaining seats to the highest decimal place, we'll modify our divisor. So with this method, you change that divisor to something smaller and then rerun all of your numbers. This is kind of a guess and check method and is much trickier than the Hamilton's method. So for the candy example, we go back to our standard quotas that we had in the previous example. Here we had 27 as our total. And so if we adjust the divisor from 25 to 24 here and repeat the process, we would divide 188 by 24, 142 by 24, each time dividing by 24 rather than 25. We end up with a total of only 28 if we drop the decimals. So we're still too low. Trying again, we can adjust the divisor to 23.5, dividing each of those populations by 23.5. We end up with 8, 6, 5.8, 2.7, and 9.2. At that point, if we drop our decimals, we end up with 8 plus 6 plus 5 plus 2 plus 9, which gives us the even 30 pieces of candy we were looking for. Looking again at our Delaware example, we have our 3 populations and our total population. We go through our initial steps just like Hamilton, find our standard divisor, find the standard quota and our lower quota. In this case, we want to adjust the standard divisor. So if you remember from that last example, the standard divisor in that case was 21,900. We want to choose the standard divisor and see if we can find the one that works. So here's our initial information. You always want to choose a number lower than your original divisor of 21,900. In this case, it's really just guess and check. If it turns out if you use 21,500, recalculate the quotas by dividing each population by 21,500. For example, here, if you're looking at Newcastle, we have 538,479 divided by 21,500. We end up with 25.0455. Let's see. And in that case, we'll get that extra seat. That 25 rounds up. Our 7 and 9 stay the same, and we have 41. So those are several examples of Hamilton and Jefferson method. I hope that helps, and if you still have questions, feel free to email me.